August 2022. London sweltered under a record heatwave. Inside a CyrusOne data center, a crisis was unfolding. Cooling systems failed, and server room temperatures soared. The CME Group, a global financial exchange, went offline. Trillions in trades halted. The digital world's heartbeat skipped. This wasn't a cyber attack, it was just too hot. Data centers, anonymous, windowless buildings, are the engine rooms of our digital lives. When cooling fails, the consequences are immediate. The London outage exposed a hidden vulnerability. Our digital world is only as strong as its weakest air conditioner. The outage was a glimpse into a future where heat could destabilize our digital society. Keeping the digital world cool is now one of the most critical engineering tasks of our time. Step inside a data center, a warehouse packed with server racks, each filled with powerful computers. These servers run non-stop, storing our photos, powering apps, and driving the global economy. Every online action, an email, a video, an AI query, means computation, and computation means heat. The CPU, the server's brain, turns electricity into heat as it works. Multiply that by thousands of servers, and the heat is staggering. A single rack can produce as much heat as a home oven. Data centers are designed for density, more computing power in less space, but also more concentrated heat. Without active cooling, temperatures would quickly destroy sensitive electronics. Up to 40% of a data center's electricity goes just to cooling. The more we use the internet, the more servers we need, and the more energy is spent fighting heat. It's a relentless cycle. More servers, more heat, more cooling. The scale is massive. A large data center can use as much electricity as a small city. Cooling isn't just a technical detail, it's a fundamental part of digital life. The battle against heat is constant, invisible, and absolutely essential. Every click, stream, or search adds to the load. The laws of physics don't care about uptime. If we can't keep data centers cool, the digital world grinds to a halt. The heat challenge is at the heart of our online existence, and it's only getting tougher. The heat problem isn't new, but AI is making it far worse. Training large AI models requires weeks of intense computation, pushing servers to their limits. Specialized chips, like GPUs, run hotter than ever. Think of a regular server as a family car. An AI server is a Formula One racer. Extreme performance, extreme heat. AI racks can use 10 times the power of standard ones, creating unprecedented heat density. Traditional cooling methods can't keep up with these concentrated hotspots. Cloud computing compounds the problem, consolidating thousands of companies' workloads under one roof. The result: more heat, packed tighter than ever. The convenience of the cloud and the power of AI come at a physical cost: heat. Managing this heat is now the defining engineering challenge for the next decade. The old ways of cooling are no longer enough. Data centers must adapt or risk catastrophic failures. The rise of AI is forcing a fundamental rethink of how we build and operate these facilities. The future of digital growth depends on solving the heat problem. The stakes have never been higher. The cost of failure is the stability of our digital society. For years, data centers relied on air cooling: giant air handlers, cold aisles, and hot aisles. Chilled air is pumped under raised floors, drawn through servers, and expelled as hot air. This cycle worked well when heat loads were lower. But air is a poor heat conductor, and modern AI servers generate more heat than air systems can handle. To keep up, operators need bigger fans and colder air, driving up energy use and costs. At a certain point, it's just not practical. Air can't move fast enough to cool high-density racks. Hotspots develop, forcing operators to spread out servers and waste valuable space. The old air cooling model is reaching its limits. The industry faces an inflection point. Air cooling can't keep up with the demands of AI and high-performance computing. Operators are running out of options. The age of air cooling is ending. A new solution is needed to handle the next generation of heat. The future of data centers depends on finding a better way. The pressure is on to innovate, or risk more outages. The next step is clear: move beyond air. The race for new cooling technology is on. As air cooling falters, the industry is turning to liquid. Liquids absorb and transfer heat far more efficiently than air. Direct-to-chip liquid cooling brings coolant right to the hottest components: CPUs and GPUs. Cold plates sit atop chips, drawing heat away and circulating it out of the server. Another approach: immersion cooling, where servers are submerged in non-conductive fluid. The fluid absorbs heat directly, eliminating the need for fans and much of the air conditioning. These methods support much higher server densities and cooling capacity. But liquid cooling brings new challenges: risk of leaks, expensive fluids, and complex plumbing. Retrofitting old data centers is costly and difficult. Still, the direction is clear. Liquid cooling is becoming a necessity, not a luxury. The demands of AI are forcing the industry's hand. The transition is underway, despite the hurdles. The future of high-performance computing depends on mastering liquid cooling. The stakes: reliability, efficiency, and the ability to keep up with digital growth. The industry is betting big on liquid. The next generation of data centers will be built around it. Data centers don't just consume electricity. They use vast amounts of water for cooling. Traditional evaporative cooling towers can use millions of liters daily, a major environmental concern. As water scarcity grows, this is unsustainable. Microsoft is pioneering a new approach: water positive by 2030. Their new data centers use outside air for most cooling, free cooling, cutting water use dramatically. On the hottest days, a closed-loop liquid system dissipates heat without evaporating water. Water tanks are reserved for only the most extreme events. This hybrid model can reduce water use by up to 95% compared to traditional methods. It's a major step towards sustainable digital infrastructure. Microsoft's design tackles both energy and water challenges. The future of data centers must balance performance with environmental responsibility. Innovation in cooling is about more than uptime. It's about the planet. As demand for data grows, sustainable cooling is essential. The industry must rethink its approach to water and energy. The cloud can't come at the cost of the environment. Cooling smarter is the only way forward. In data centers, uptime is everything. 5 nines or 99.9999% availability is the gold standard. That's just 5 minutes of downtime a year. Outages are rare, but when they happen, the impact is huge. Lost trades, lost sales, lost trust. Data centers power hospitals, banks, governments. Failure isn't an option. Operators build in layers of redundancy backup generators, UPS, and cooling systems. If one system fails, another takes over instantly. The cost of downtime is measured in millions. The London outage was so shocking because it broke this trust. The growing heat challenge threatens even the most robust systems. AI-driven heat loads can overwhelm traditional redundancy. A cooling failure could become a systemic failure. Maintaining 5 nines uptime now requires new investment and innovation in cooling. The stakes are higher than ever. The digital world depends on reliability. The margin for error is shrinking. The future of uptime is tied to the future of cooling. The industry is investing billions in next-generation cooling. It's not just about keeping servers running, it's a race for digital dominance. Tech giants like Google, Amazon, and Meta are betting on liquid cooling and custom solutions. New data centers are being designed from the ground up for high-density, liquid-cooled deployments. The supply chain is retooling for this new reality. Cooling innovation is now a key competitive advantage. Sustainability is part of the equation. Features like Microsoft's water-saving designs are becoming standard. The data centers of today look nothing like those of a decade ago. They're bigger, more powerful, and more efficient. The industry's future depends on solving the heat problem. The billion-dollar bet digital growth without overwhelming our energy and water resources. The transformation is underway. The winners will be those who keep their cool. Cooling data centers is now one of the most critical engineering challenges of our era. The rise of AI and cloud computing has made traditional air cooling obsolete. The shift to liquid and advanced solutions is reshaping the digital world's foundation. Without effective cooling, digital progress stalls. The London outage was a warning. Our digital world is built on a physical foundation that's getting hotter. Sustainable, efficient cooling is essential for continued growth. Every design choice, from microchips to building location, matters. The future of the internet depends on solving the heat problem. Innovation in cooling will drive progress in AI, science, and business. The race to stay cool is hidden, but its impact is universal. Securing our digital tomorrow means building infrastructure that can handle the heat. The choices we make now will shape the digital world for decades. The future must be cool.